This lecture is organized by Dr. Alemi. The lecture is part of an open intro statistics book. We quantify the probability of an event so that we can make trade-offs among uncertain events, measure the combined impact of several uncertain events, or communicate our uncertainty to others. An element is the smallest unit of the analysis. It is counted to construct events. For example, in analysis of medication errors during a visit, one may consider the visit an element. Events are a grouping of elements. For example, all visits in which a medication error has occurred may be considered a medication error event. A collection of all possible events is the universe of possibilities. A Venn diagram shows the universe of possibilities, events, and sometimes, though not usually, the elements. Venn diagram is very useful in having intuitions about probabilities. To create a Venn diagram, we start with a rectangular space that depicts all possible events. The yellow circle shows the frequency of the event A among all possible events. The blue portion of the rectangle shows the frequency of events that are not A. This visualization helps us define what is probability. The best way to think of probability is as the ratio of all ways in which an event may occur divided by all possible events. In short, probability is the prevalence of the event among the possible events. Count what is possible and ways in which the event of interest may occur, and you can calculate a probability score. The probability of a small business failing is then the number of business failures divided by the number of small businesses. Here the rectangle represents all businesses and the yellow circle shows failing businesses. The ratio of the two shows the probability of failing businesses. The probability of an iatrogenic infection in the last month in our hospital is the number of patients who last month had an iatrogenic infection divided by the number of patients during the last month. Probability can be calculated from repeated observations. Suppose we want to know what is the probability of rolling a die and getting a 1. Theoretically, this is 1 divided by 6, as there are 6 possible numbers on the die, and the number we want to get is one of them. The y-axis here shows the estimate of the probability. The x-axis shows the number of times we have thrown the dice. In a small number of trials, in this case in the first 10 trials, the probability of getting 1 out of 6 could be way off. As the number of rolls increases, the estimate of the probability converges to the theoretical probability. The law of large numbers says that as more observations are collected, the estimate of probability becomes more accurate. This is important because it tells us we can get to the truth by repeating the observations. When we are sure something will happen, then the probability of it is 1. When we think an event will never happen, then its probability is 0. When we are completely uncertain, then the event has a probability of 1/2 or 50%. All other frequency adverbs do not have an exact numerical probability associated with them, but they have a rough number. Some people prefer to describe their uncertainty about an event in terms of odds for the event. The two concepts are related. Odds are expressed as ratios, while probabilities are expressed as decimals between 0 and 1. The odds for an event is equal to the probability of the event divided by probability of its complement, or 1 minus probability of the event. If we have the odds and want to calculate the probability of an event, we can do so by dividing the odds of the event by 1 plus the odds of the event. For example, if the probability of an event is 90%, the odds for it is 0.9 divided by 1 minus 0.9. In other words, the odds are 9 to 1. Odds and probabilities are always positive numbers. There is no upper limit to an odd ratio, but the maximum probability is 1. An odds of 1 to 1 implies a 50% chance of a probability. Odds of 2 to 1 increases the probability of the event to 0.66. Odds of 3 to 1 increases the probability of the event to 0.75. And odds of 4 to 1 increases the probability of the event to 0.8. Managers often talk of probability of one-time events. Many talk of probability of events that have not occurred. For example, a manager may want to know the chances that a particular legislation will limit hospital reimbursement. Other managers talk of events that occur only once or twice, so we cannot reliably sample the event and calculate its probability. For example, they may want to track the probability of wrong-side surgeries. In these circumstances, the definition of probability as count of event is not very helpful. We need a new definition that does not involve counting. A number between 0 and 1 can be given to our opinion about the probability of an event. If these numbers meet certain axiomatic restrictions, then the numbers could be considered proper probability functions. Any set of numbers that follow 4 axioms are defined to be a probability function. The 4 axioms are the following. First, at least one of the possible events must happen. This is easy, and most people agree to this. Second, probability of any event is greater than or equal to 0. Again, this is easy. We can agree to assign only positive numbers between 0 and 1 to our opinions. Third, probability of a complement of an event is 1 minus the probability of the event. This may not occur all the time, but we can agree that this should happen, and that is proper for us to hold opinions such as this. Fourth, the probability of 2 mutually exclusive events is the sum of each. Mutually exclusive means that they have no elements that overlap. This last axiom is often violated, but we can agree that our numbers should follow this rule also. If numbers can be assigned to events such that these four axioms are met, then these numbers are a probability function and follow the calculus of probability. In their thinking, experts may or may not follow the calculus of probability. But what people do and how they should do it are two different issues. People may wish to follow the rules of probability even though they have not always done so. Experts' opinions may not follow the rules of probability, but if experts agree with the axioms that the axioms are reasonable and should govern their estimates, then such opinions should follow the rules of probability, and the calculus of probability can be used to find the implications of their estimates. Here is an example of how subjective probability can be measured on the basis of intensity of feelings. Several experts familiar with the process can be asked to mark a scale between 0 and 100. Probabilities, whether counted from events or asked from experts, provide a context to study beliefs. Rules of probability provide a systematic and orderly method of calculating probability of several events from probability of an individual event. The take-home lesson for this lecture has been that one definition of probability is the count of the event of interest divided by count of all possible events. See if you can answer the following question.